Hello, our most valued student. My name is Confident. Welcome to our revision of the Mathematics N1 question paper. This question paper was written actually in July, but it is because of the suspension of the academic term due to the COVID-19. But at the end of the day, this paper was written in July. So in this particular section, I'm going to give you a revision whereby I will show you some ideas or some strategies that you could have used to solve this question. It can work for you whenever you want to prepare for your final exams. So as I said, this is Mathematics N1. It is a national senior certificate by the Department of Higher Education, and this is the code of the paper. And let us look at a few requirements and some instructions. It says you need a graph paper to solve, as part of this question. And then it says non-programmable calculators may be used. It says this question paper consists of 6 pages and a formula sheet of 2 pages. And a few instructions. It is always important for you to read the instructions so that you can take note of things that you are expected of. So as I said, this is a Department of Higher Education and Training. It's a national certificate, Mathematics N1, and the time for this particular paper is 3 hours. So you've got 3 hours to complete it, and the total marks is out of 100 marks. And these are the instructions. There are 8 instructions that we provided. The first one says you need to answer all the questions, read all the questions carefully. And then it says number the answers according to the numbering system used in this question paper. So do not come up with your own numbering system. For example, you might find that a question is, you have got question 1.1. Now, a student wants to number their own to say 1.1.1 of that question, which 0.1 is not given. It means that you are now coming with your own numbering. So do not come up with your own numbering system except the one that is given. And then it says questions may be answered in any order. So you can start with question 5, you can start with question 6, you can start with question 2. But now it says in this particular case, subsections of questions must be kept together. So whenever you start a question, you need to complete the whole question so that you don't mix 1.1 maybe with 1.2 and then 1.3. So you can't mix questions. For example, you can say this is question 1.1. Now you don't know question 1.2, then you go to question 2.1. So you see that you are mixing subsections and they are saying this is not allowed. And then says question 5.1.3 and 5.2 must be answered on a graph paper. So you must follow that instruction. Whenever we come to that part, I will also emphasize. Then it says use only black or blue pen. Please do not use some Tipex. They are not allowed. Do not use some colorful pens. They are not allowed. Just a blue or a black pen is sufficient enough. And then says round off answers to 3 decimal places unless indicated otherwise. And then says write neatly and legible. When it comes to write neatly and legible, make sure that if you make an error, you scratch. For example, if let's say this is your page like this, you have your page, and let's say you make an error, you're writing and you make an error and you decide you want to cancel. Just take a ruler and then make a cross like that to show that this has been cancelled. So you don't have to be clumsy with your work. You just need to be neat, and they will actually penalize you if you're not neat and your writing is not clear. And also, if you want to do your working, you are allowed to go to the back of your answer sheet and do all your working, and then you cross out that rough work as and you can even write on top and say this is my rough work. So you can say this is rough work, so that they do not include it as part of your marking. Now let us dive into this question. In this section, we're going to look at the whole of question 1, so including its subsections. So the first question number 1 says, simplify the following using exponents without using a calculator. So in this whole section, you are not supposed to use a calculator. And I always say, whenever they say do not use a calculator, if possible, you need to use a calculator as a verification of your answer. Now let us start with question 1.1.1. You are given the exponents a to the power of 3 times a to the power of 2 times 2a to the power of 0. Now what I want you to notice here is, okay, this was out of 2 marks just to begin with. So it is 2 marks that were worth grabbing there. If I can expand my screen there. So this is what you're given. You are supposed to expand that. Now for you to expand that, there are a few things I want you to notice. The first part that I want you to notice is this particular part, to say it is to the power of 0. Now notice that the power of 0 is only affecting a there. It is not affecting 2. And now you must remember that any number to the power of 0 is equal to 1. For example, if you take your calculator and then you say 50 to the power of 0, you see that it is 1. So already that was the first hint to say any number to the power of 0 is 1. So here, if I can do my work to say a to the power of 0 is equal to a 1. And also using the laws of exponents, this is the first law of exponents, to say if you are given x to the x, okay, let me just do this. If you are given in terms of a, if I'm given a to the power of x and then times a to the power of y, now when the bases are the same like this, and then what you must do, it says you must add the exponent. So you write a and then you have x plus y. So this is what we are going to apply in the first two. There you can see the bases are the same. So we are going to have equal to a to the power, we have got 3 plus 2 times 2. Remember, a to the power of 0, we said this is, you can put a bracket or you can say times 1 like that. Then this becomes a to the power 3 plus 2 is 5. 2 times 1 is 2. So this symbol becomes 2a to the power of 5. So that is how you are going to get your 2 marks into that part. It wasn't a difficult question. It was just a simple question that you needed to follow through using your laws of exponents. Now question 1.1.2, in this case we are still continuing. It says we must simplify without using a calculator. This particular question was 4 marks. And then if I can expand my screen so that it can be visible. So what am I having here? It says I must simplify this expression, and let me just again have my working on the side. So now there are a few things that I want you to take note of. For example, let us take note of this particular expression to say I'm given 4x y. Now there is a 2. So when you can see the 2 is on the outside, it means this particular power will affect each and every one of these. So now the next thing that you also need to remember is each one is to the power of 1. For example, 4 to the power of 1, x to the power of 1, and y to the power of 1. And how do you simplify that? There is a rule which says if you are given, for example, a b, and then I have got x to the power of y. Just want to demonstrate that it is not exactly like that. Let's say that is to the power of 1. So what happens is the a will be 1, the y will multiply that 1, and the y will multiply this x. So it's 1 times y dot b x times y. So you see that it is multiplying. So if we can use the same rule in here, it will be 4 1 times 2 dot x, and it's 1 times 2 dot y, and it is 1 times 2. So if we simplify then this as final part, it will be equal to 4 squared x squared and y squared. It was possible for you to go directly from here to here without having to pass through the 1 times 2, 1 times 2, and 1 times 2. So this is the first part that you need to notice there. And the second one that I want you to also notice is this bracket, which is 5x y to the power of 0. Now I want you to notice that the power of 0 is affecting each and every part of what is inside. So this particular 0 is affecting 5, it is affecting x, it is affecting y. Now you must remember, any number to the power of 0 is equal to 1. So whatever case the number is, if we can take any number, I can choose, maybe I can say in bracket 1 times 5 times 9, any number, and then I say to the power of 0, it will simply become a 1. So that is what you need to know. Now when you have done that, we can therefore try to simplify this expression to say what we have here is equal to 3x squared y to the power of 3 times, then this is 4 squared x squared y squared times 1, and then all over 4x to the power of 4 y to the power of 3. So this is the first part. Now the other interesting thing that you needed to know whenever you are dealing with exponents, there is a rule which says if I'm given, for example, 1 over, in this case, for example, I can say 1 over a squared. Let me make x in this case 1 over a to the exponent of x. So if I'm given that part and I want to take the a to the power x on top, in other ways, I want to get rid of this division line and remove it. So if I want to remove that division line, what I need to do using the law, there is a law which says I must say a to the power. Now to remove that division line, I put a negative and then is equal to x. So is equal to a to the power negative x. So that part is the way of removing this division sign that was there. Now similarly, if I'm given, for example, in this case, if I'm given 1 over 3x y squared, see, if I'm given that, if I want to take the 3 on top, it will be 3 to the power negative 1. If I want to take the x, now you must see that the squared is only affecting y, the x there is a 1, so it will be x to the power negative 1, and then it will be y to the power negative 2. So the negative sign is an indication that we have removed this division sign. So we can do the same thing with our division sign here. So you see, I have a division sign and I want to remove this division sign, and 4 is to the power of 1. So I'm going to take 4 to the top. I'm also going to take x to the top. I'm also going to take y to the top. So for me to be able to do that, this will be equal to 3x squared y cubed times 4 squared x squared y squared, times 1 will not change anything, and then I'll say times 4 to the power 1 will become 4 to the power negative 1, and then x to the power 4 will become x to the power negative 4, and y to the power 3 will become y to the power negative 3. So this is how you were supposed to, they were testing if ever you know that law of the second law, where the law when it's division. Yes, it's the second law in a way to say when it's division you subtract or you put a negative. Now when you have done that, everything is now flat and it is multiplying. You can use the law where for multiplication part, whereby you need to say, if you remember, it says a to the power of x times a to the power of y. I did it in the first part. In the first question, it was this law that they were testing, and I said when the bases are the same, what you need to do is to add the exponents, which is same as a to the power x plus y. So what we need to do here is to identify things that are the same, and we collect in a way some like terms and apply the law. So let us collect some like terms. We start with the numbers. I have got 3 times, I have got 4 squared as the first one. Just I'll be marking it so to see that I don't lose anything there. 4 squared, and then there it is, times 4 to the power negative 1 times, I have done on the numbers. Now let me go for x. I have got my x squared there, times, I also have my x squared there, times, I also have the other x is there, which is x to the power of negative 4, and then times, done with the x, I've got my y there, which is y to the power of 3, and then times, I've got my other y squared there, and then times, I've got my y to the power of negative 3 there. So you can see I've managed to, I was marking them so that I can ensure that I didn't leave out anything. I will always encourage you to mark, though you must use for example a pencil, so that you can always erase when you're done marking this. This is just to avoid errors whereby I've seen students forgetting some of the parts here. You find that you can forget an x or an y, and then after doing all the work your answer becomes wrong. So by marking, you're trying to ensure that each and every expression was not forgotten. So now we are going to be applying this particular law here. As I said, it is the law whenever the bases are the same. So let's follow where the bases are the same. It is equal to 3 times. Now look at the first part. We've got 4 and 4. So the bases are the same. So you'll have 4, 2 plus minus 1. Remember, you must add. And then times, not plus, times. Again, we have x, x, and x. So the bases are the same. So you will have x, which is 2 plus 2 plus minus 4, and then times. Again, you can see the y part is got same basis, which in this case will be equal to y to the power of 3 plus 2 plus minus 3. And I know they said do not use a calculator, but if you are not good with your addition and subtraction, especially the negative, always test with your calculator. For example, 2 plus minus 1 there, you need to say 2 plus negative 1. You can see it's giving me a 1. Let me just add the rest. Again, the second one is 2 plus 2 plus minus 4. You see it's giving me a 0. The other one is 3 plus 2 plus minus 3, it is giving me a 2. So you can always use your calculator so that you don't make errors. So here we have got 4 to the power 1 times x to the power of 0 times y to the power, as we said, of 2 there. When you have done that, this can still continue to become, in this case, now you see you have got power of 0, and you said any number to the power of 0 is equal to a 1. So it will further become 3 times 4, which is 12 times 1, in this case, times y squared. And then you can be finding your final answer as 12y squared. So this is how you were supposed to simplify that question, mainly using the laws of exponents. Now let us move on to the next question. It says simplify the following using using exponents without using a calculator. It is still question 1.1 of 3, and this question is 3 marks. And if I can also increase my screen there. Now let us look at this question. This is what I are given here, and now you need to simplify without using a calculator. And if I can again divide my page. Now I want you to notice something here. Each and every one, you need to be careful here, whereby they wanted to test your how in terms of your laws of exponents, how sensitive you are with your exponents. For example, if you are given this sign and they put an x here, you must know that it is the same as saying put a bracket and say 1 over x, right? So which means if they gave a 4 there, this is same as saying bracket and it's 1 over 4. Now if they don't give any number, if they just give it like that, in this case it is the second bracket here. If they don't give any number, you must know that this is equal to 1 over 2. Why? Because this is square root, and square root, there is a hidden 2 there. So remember that always. So that is the first part that I wanted you to take note of. So which means if they gave you, in this case, a 4, if we can say this continues to be equal to, they gave us a 4 there. Now this particular 4, we're supposed to say this is 16 x to the power of 4, y to the power of 8, and then you're going to say 1 over 4 times 1 over 3, again put a bracket, which is 81 x squared y to the power of 6 to the power 1 over 2. So this is where they wanted to catch you on. Look at how we did our 1 over 4 and look at how we did our 1 over 2. So that is the main part that they wanted you to check there. And the next thing that you need to do is to identify what is your 16. You take a calculator there and check. There is always a hint. For example, 16 and 1 over 4, you can try 16. 16 is 4 squared. It is 16, but 4 again is to do with 2. So what about 2 to the power of 4? 2 to the power of 4. You see it is 16. So there is a hint between 1 over 4 and you can express 16 in terms of 2. Again, what about our 81? Our 81 there is 9 squared in there. If I say 9 squared is 81. But just to go ahead of myself, you see there is a 3 there, 1 over 3. So I can put 81 in terms of 3 maybe. I say 3 to the exponent 4. 3 to the exponent 4 is also 81. So it is better for me to write it in terms of 3 so that 1 over 3 will also be solved at the same time. So if I simplify that, I will have, in this particular case, what I'm going to have here will be, Remember, 16 is 2 to the power of 4, x to the power of 4, y to the power of 8, and this is 1 over 4 times 1 over 3, and then I've got now 3 to the power of 4, x squared, y to the power of 6, 1 over 2. And we did look at this law previously to say whenever you're given a law which says, for example, a times, for example, a to the power of x and b to the power of y, and then you put a bracket, and then let's say you multiply by z. This particular z will multiply x and it will multiply y, so that it will be a to the power x times z dot b to the power y times z. So you can see that the z is multiplying x and y. So similarly, here we have got 1 over 4 multiplying each and every exponent there, and then we've got also 1 over 2 multiplying each and every exponent there. So this will then become, in this case, 2 to the power 4 times 1 over 4, x to the power 4 times 1 over 4, y to the power 8 times 1 over 4. Remember, these are exponents, so you must write them as exponent, times 1 over 3 times 3 to the power 4 times 1 over 2, x to the power 2 times 1 over 2, and then y to the power 6 times 1 over 2. So this is the next simplification that was you're supposed to do, and then you can now cancel out 4 and 4 there, the 4 and 4, the 4 and 8 will give you a 2 there, the 2 and 4 gives you a 2 there, the 2 and 2 cancels, and the 2 and 6 gives you a 3 there. And then if you further simplify, then you'll have 2 to the power of 1, which is 2, and x to the power of 1 in this case, which is x. You can make it 1 1 there, and then we've got y to the power of 2 times 1 over 3, and then times 3 to the power of 2 times, even if I don't put a times there because I didn't include it, I just have to say x to the power of 1 and y to the power of 3. So that is that. And then you can now simplify further. You can collect like terms, but quick one is, you can see 1 over 3 and 3 squared there, it can actually cancel because 3 squared is 3 times 3. In other ways, if I say if I can do this and say 1 over 3 times 3 squared, which is 3 times 3, you can see that one of them cancels and then you're left with 3. Or you can apply a law. Remember, 1 over 3 is same as 3 to the power negative 1. So you can apply a law which says 3 to the power negative 1 times 3 squared, which is equal to 3 to the power minus 1 plus 2. Now minus 1 plus 2 is 3 to the power of 1. So whatever case, you still get a 3. So if I can cancel there, this 3 will cancel the 2 to remain with a 1 there. And then I can collect my like terms, start with the numbers, which is 2 times 3, and then x to the power 1. As I said, it's good to mark this. I've collected that x1, and there is my other x to the power 1. And then y to the power 2. And then I've got the other one, which is y to the power of 3. And then 2 times 3 is 6. I'm using my first law of exponents. The bases are the same, so I'm going to add those. And then again, y, the bases are the same, I'm going to add those. So it is 1 plus 1, y2 plus 3. So when I simplify this finally to be 6x squared and y to the power of 5. So basically this is how this whole question was simplifying, and I think it wasn't as complicated, but it wanted you to be extra careful with your addition and subtraction. Now let us move on to question 1.2. Now this is a new question, 1.2, but it's still under question 1, and we are looking at 1.2.1, and this particular question was out of 4 marks. So if I can also expand my screen there, we are solving logs, and then the question was simplify. It says simplify the following logarithms without using a calculator. Now there is the good part whereby I like to take my calculator and see what is my final answer here. So I punch log 5. Remember, when it opens a bracket, you must close the bracket, plus log, you see there is an open bracket, 2, and I must close the bracket, over log 20. If you don't close the bracket, when you say plus, you see that whatever you're punching or you're entering is now inside that bracket, making everything wrong. So plus log 5 plus log 20, divided by log 20 plus log 5. And my answer is 1 over 2. So I can write my answer here and say I'm going to get 1 over 2. Remember, it's just to know your answer there. Now the question is, how did the calculator get 1 over 2? Now the first part that you need to do is remember the laws of logarithm. The first law says if you're given log in base of x of a plus log in base of x of y, this is equal to, now you can notice that the bases are the same. It's xx. Actually, I didn't want to change here. Let me just maintain and say b there because I've got my a. Let me make it in terms of b. So now you can see my bases are the same, xx. So this will be log in base x, since the bases are the same. Now you say a and b, because of the positive sign, you'll say a times b. So this is a law that is important that you need to know, that we're going to use in this particular case. Now if they just write, in this case they say log 5, what you must know is log 5 is same as log base 10 of 5. Sometimes the 10, if it is not included, we always leave it out. By default, the base there, if it's not given, it is always log base 10. So which means we can rewrite this whole thing and say it is same to say log base 10 of 5 plus log base 10 of 2 over log base 10 of 20 plus that's what actually it means, log base 10 of 5, if ever you're including the bases. Now applying the law on top, remember there is a plus sign. You can see there is a plus sign there, and as I said, the bases are the same, so you can apply the law and then want to say this is log base 10, 5 times 2 over log base 10, 20 times 5, right? If I simplify that, 5 times 2, which is log base 10 of 10 over log base 10 of 100. So this is how it goes. Now the next thing is to know also the law. There is a law of logs, which says in this case log base a of a. So when the base and the number is the same, you get a 1. You can prove that with a calculator. For example, if I take log and then I say 2 of 2, so when the number and the base are the same, you can see that I get a 1. So now this is the scenario that I'm having here on top. You can see I've got 10 of 10, so it is equal to 1 over. Now the next part is 100. Remember now, I'm given log base 10 of 100. Now remember, 100 is same as log base 10, and 100 is 10 to the power of 2. So that's what I'll be having there. So it's same as saying log in base 10 of 10 to the power of 2. So with that, I have a law again. There is a law which says if I'm given log in base a of x to the power of y is equal to, now there is a law which says that exponent, you can drop it so that it becomes, in this case, y. You see the exponent is dropped there, and then you write your log a to the power of x. So this particular exponent can join the number before the log. Similarly, this particular 2 can drop so that it becomes it comes before the log, and in this case what you are going to have then will be equal to 1 over, and then you have got, it's 1 over 2 log base 10 of 10. So now remember again, we are back to saying log base 10 of 10 is 1, which is 1 over 2 times 1, which is 1 over 2. And if you still remember, we did prove that our answer was 1 over 2, which is correct. Now I will also want to emphasize that there were many different ways you could have approached this. It is also possible for you to have chosen another direction, especially from this stage, whereby you could have said here, I don't want to simplify using this law, and you leave it like this, log base 10 of 10 over, and then you take this one here, which is 2 log base 10 of 10. You can see that you cancel now. 10 of 10 is 1, 10 of 10 is 1, and the answer there becomes 1 over 2. So this is different ways that you could have approached this. All right, now let us move on to the last part. I'm saying the last part because you can see that the total there is given out of 14, meaning the whole question number 1 was out of 14 marks. And then let's go to this 1.2.2. Again, it says simplify the following logarithms without using a calculator. So this is what we are given in this case. And if I can then take my calculator, because it is always good to know where you're going. So log, I'm given 7 log 10. Remember, I told you when you're just punching log, it means already it is in base 10, minus, and then 1 over 2, and then you punch that in so that you can put a base of 64. Now when you do that, I'm getting my answer of 4 there. So the question is, how do I get this particular 4? Now let us apply the laws of logarithms so that we can see how they got this 4. The first part is this number log 10. Now if you are giving me log 10, remember the base is same as saying log in base 10 of 10. When it's repeating like that, simple, what it means, it is equal to 1. You can even take a calculator and ask yourself, what is log 10? You can see that log 10 is simple 1. What they are doing is like saying log 10 of 10, which is a 1. So that part done. The next part that I want you to take note of is this part, which is log base 2 of 64. Now the key thing is, how can I express 64 in terms of 2? So you take your calculator and say 64 and 2 are related. For example, 2 to the power of 5, 2 to the power of 5, it is 32. 2 to the power of 6, it is 64. You need to know such things. So which means I can express that and say 64 is same as log base 2 of 2 to the power of 6. And also I will remind you to say if there is a power, you can drop that particular 6 down there. So now let us solve it and see what it becomes. In this case, I'll be having 7 log base 10 of 10, just to justify my 1, minus 1 over 2 log base 2 of 2 to the power of 6. And then this becomes 7 times 1 minus 1 over 2. Now I'm going to drop this 6. When I drop it down, it comes and multiplies 1 over 2. So it's times 6, or you can put in brackets in this case. You can actually use this and say 1 over 2 into 6 log base 2 of 2. Now you are again seeing that the number and the base are the same. Remember, this becomes a 1. So 7 times 1, it is 7 minus 1 over half of 6 is 3. So minus 3 times log 2 of 2 is a 1. So what is 7 minus 3? 7 minus 3 is equal to 4. So this is what I was saying to say the calculator can actually assist you to see where they were getting these answers. Now we have come to the end of this section where we're looking at question 1 of Mathematics N1. This paper was written in July 2020. I hope this was of benefit to you. If you benefited, I will encourage you to use these strategies as you prepare for your final exams. Thank you.